There's a factory in Connecticut that's been building America's standard military rifle since the Vietnam War. Same family of weapons, same trust from the Pentagon, decade after decade. And the M16A4, the rifle carried by soldiers on the front lines, comes from a process most Americans have never seen. Precision machining, hand assembly, testing that leaves zero margin for error. Today, we're going inside. A military rifle isn't just a weapon. It's a piece of equipment a soldier's life depends on. It has to function in sand, in mud, in extreme heat, in freezing cold, without failing. And it has to do that every single time, with zero exceptions. What you're about to see is how the M16A4 actually gets built. From raw steel and aluminum, all the way to a fully assembled, tested, and certified rifle ready for military service. Coming up, we're walking through the complete manufacturing process. But there's one specific stage where every single rifle either passes or gets pulled from the line completely. No second chances, no compromises. We'll get there. Let's start from the beginning. Let's start with something most people never think about. A rifle looks simple from the outside. A barrel, a stock, a trigger. But the M16A4 is made up of well over 100 individual components, each one manufactured to extremely tight tolerances, each one tested before it ever gets assembled into a finished weapon. And here's the part that should give you pause. If even one of those components is off by a fraction of a millimeter, the entire rifle can fail. Not perform poorly. Fail, jam, misfire. In combat, that's not an inconvenience. That's a life or death difference. And everyone on this factory floor understands that every single day. So how does a factory guarantee that doesn't happen? Not occasionally, not most of the time, but every single time across tens of thousands of rifles year after year. It starts with the raw materials. Every M16A4 begins as raw forged and machined aluminum and steel. Specific alloys chosen for their strength, to weight ratio, and their ability to withstand repeated stress without fatiguing or cracking over years of service. The receiver, the central housing that holds the rifle's internal mechanism, is forged from aircraft-grade aluminum, the same category of material used in aerospace applications where failure simply isn't an option, where a single defect could bring down an aircraft instead of just one weapon. Before any of this material gets shaped into rifle components, it gets tested. Metallurgical testing verifies the composition and structural integrity of every batch. Because a flaw at the molecular level, invisible to the naked eye, could mean a part that looks perfect but fails under the stress of repeated firing. This is the first checkpoint in a long chain of checkpoints, and it sets the tone for everything that follows. Nothing moves forward until it's verified, and nothing gets a pass just because it looks fine. Once the raw aluminum forging is approved, it moves to CNC machining, computer-controlled cutting tools that carve away material with extraordinary precision, shaping the rough forging into the lower and upper receiver, hubs that form the rifle's core structure. This stage transforms a rough, unrecognizable block of metal into something that's already starting to look like the rifle it's destined to become. This is where tolerances become critical. The receiver has to accept dozens of other components, the bolt carrier group, the trigger assembly, the magazine well, and every single one of those interfaces has to align perfectly. If the machining is off by even a small fraction, parts won't see correctly, won't function smoothly, or worse, won't function safely, creating risk that simply isn't acceptable in a combat weapon. Each machined receiver gets inspected using precision measuring equipment, verifying that every dimension matches the engineering specification exactly. Receivers that don't meet spec get rejected immediately. They don't get fixed or pushed through anyway. They're pulled, logged, and set aside. And the line keeps moving with parts that actually meet standard without exception. If there's one component on this rifle that receives more attention than any other, it's the barrel. The barrel has to withstand extreme heat and pressure, repeatedly, while maintaining the accuracy the rifle is designed to deliver, shot after shot, for the entire service life of the weapon. It starts as a steel blank, which gets drilled, reamed, and rifled. A process that cuts spiral grooves into the interior of the barrel, causing the bullet to spin as it travels through, which stabilizes its flight and dramatically improves accuracy over distance. This rifling process has to be exact and completely consistent from one end of the barrel to the other. Any inconsistency translates directly into accuracy problems downstream, problems that would only show up after the rifle is in a soldier's hands, in the field, when consistency matters most and there's no opportunity to send it back for adjustment. After machining, barrels undergo a hardening and stress-relieving heat treatment, which strengthens the steel and helps it withstand the repeated thermal cycling of being fired hundreds, sometimes thousands, of times over its service life. Following heat treatment, every single barrel gets tested, checked for straightness, checked for bore consistency, checked for any defects that could compromise performance or safety, with results logged and verified before that barrel ever moves to the next station. Deep inside the rifle sits the bolt carrier group, the component responsible for cycling each round, extracting spent casings and chambering the next one over and over, every time the trigger is pulled thousands upon thousands of times throughout the rifle's service life. This is arguably the most mechanically demanding part of the entire rifle. It has to move with incredible speed and reliability, cycle after cycle, under the extreme heat and pressure generated by firing. Manufacturing this component requires multiple precision machine parts: the bolt itself, the carrier, the firing pin, the extractor, all fitted together with exact clearances that allow smooth movement without excess play that could cause malfunctions, jams, or worse. Each bolt undergoes its own series of tests, including verification of headspace, the precise distance between the bolt face and the chamber when the action is closed. Get this measurement wrong, even slightly, and you risk serious malfunction or failure. This is a checkpoint where there's genuinely zero tolerance for error, and every single bolt gets verified individually before it's allowed to move forward into assembly. Once every individual component has passed its own series of inspections, the rifle moves into assembly. And here's something that surprises a lot of people. Despite all this advanced machining and computer-controlled manufacturing, final assembly still relies heavily on skilled human hands. Hands that have been trained specifically for this work. Technicians fit the upper and lower receivers together, install the trigger assembly, attach the barrel, install the bolt carrier group, and add the remaining components: the stock, the pistol grip, the sights, the handguard. Each step follows a precise sequence, and at several points throughout assembly, technicians perform function checks, verifying that the trigger engages correctly, that the safety functions properly, that every moving part operates smoothly without binding or excessive play. This isn't a rushed process. Building a rifle that a soldier's life will depend on requires attention that simply can't be sacrificed for speed, no matter how much pressure exists to move units faster. Every technician working this line has been trained extensively, and many have years, sometimes decades, of experience specifically with this exact weapon system, knowledge that gets passed down to newer technicians over time. This is the stage we mentioned in the introduction, the one where every rifle either passes or doesn't move forward at all, no matter how much time and material has already gone into building it. Once fully assembled, every single M16A4 undergoes function and proof testing. This isn't a sample-based check, where a percentage of rifles get tested and the rest are assumed to be fine. Every rifle, every single one, without exception, regardless of how the production schedule looks that day. Function testing verifies that the rifle cycles correctly through multiple firing cycles, that the safety engages and disengages properly, that the trigger pull meets specification, and that there are no malfunctions during firing. Technicians fire each rifle under controlled conditions, checking for proper extraction, proper ejection, and reliable feeding from the magazine, watching closely for anything that deviates even slightly from expected performance. Then comes proof testing, firing a specially designed overpressure round through the rifle to verify that the barrel and receiver can withstand pressures well beyond normal operating conditions. This is a deliberate stress test designed to reveal any weakness in the metal or any flaw in manufacturing before that rifle ever reaches a soldier. If a rifle doesn't pass, if there's any sign of stress, any deformation, any malfunction, it gets pulled from the line immediately. It doesn't get a second chance. It doesn't get shipped with a note. It's removed entirely, and the issue gets investigated thoroughly to ensure it doesn't happen again across the rest of the production run. This is the checkpoint that exists specifically because there's no acceptable margin for failure in a weapon that's going to be relied upon in combat, where the cost of a mistake isn't measured in dollars. After passing function and proof testing, each rifle goes through a final visual and mechanical inspection. Inspectors check for any cosmetic defects, verify that every component is properly installed and torqued to specification, and confirm that all serial numbers and markings are correct and traceable down to the smallest detail. This traceability matters enormously. Every rifle that leaves this facility can be tracked back through its entire manufacturing history. Which batch of steel became its barrel, which technician performed final assembly, which test results it passed, and on what date each stage occurred. If an issue is ever discovered down the line, this documentation allows the facility to trace the problem back to its source and address it across the entire production run if necessary, rather than guessing at where things went wrong. Only after passing every single one of these checkpoints does a rifle get certified, packaged, and prepared for shipment to military units, carrying with it the accumulated verification of dozens of inspections, tests, and human hands. And somewhere on that production line right now, another rifle is moving through these exact same stages, destined for a soldier who will trust it with their life, without ever knowing the name of a single person who built it, tested it, or certified it ready for service. Here's what's really worth understanding. A rifle starts as raw aluminum and steel, nothing more. It gets forged, machined, rifled, fitted, tested, fired, and inspected over and over at every single stage by people who understand exactly what's at stake if they get it wrong. And by the time it leaves that factory, it's not just a weapon anymore. It's the accumulated weight of every checkpoint it passed, every technician who verified it, every test it survived without failure. That's the part most people never think about when they see a soldier carrying a rifle. They don't see the metallurgical testing. They don't see the headspace verification, the proof testing, the hands that fitted every component with absolute precision. They just see the finished product. Reliable, ready, trusted completely. But that trust isn't automatic. It's built. Piece by piece, inspection by inspection, in a building most Americans will never set foot in. And it's exactly why a soldier can pick up that rifle anywhere in the world under any conditions and know, without a single doubt, that it's going to work. If this kind of precision manufacturing story is what you're here for, hit that like button, subscribe, and stick around. And if you want to see what goes inside that rifle, go check out our video on how military bullets get made. Same level of precision, completely different process, equally fascinating. Drop a comment below. Tell us which factory or weapon system you want us to go inside next. Your suggestion might just become our next video. See you inside the next one.